So another day, another update on the Poppiescaster, and what you can see just now is I am printing pretty yellow magnetic drawer for plectrums. It is an idea that I had, but then it turned out someone else had already designed one, so that saved a bit of time. And that's one of the things that I really like about the 3D printing community, the way that people customise other designs. And you can, if you look in that white tub to the side of the printer, you'll see the printer poop. So the reason that I'm printing things that really you don't add until the very end is because you have to check that they fit. So I have never printed this drawer before. I'm printing it in yellow because I'm hoping that maybe this will just fit and won't need to be reprinted. You might see on the one on the left, that's a hole where a 7mm by 3mm magnet will go. So hopefully that will help to hold it in. One thing that I hadn't considered at the start of the project was how I might want to hold the guitar together. Full screen, as you can see, there are two holes there. There are a selection of holes here, but really the two big holes at that side here, they're for the wiring to come through from the core. The three smaller holes are for, this is a longer one just for an example, for where bolts will go through, and on the other side they will go into these threaded inserts. So here you can see the bolt through the guitar with the threaded insert on the other end. The bolts that I'll be using won't go through all the way through the threaded inserts. This is just so you can actually get a good look at it. And these threaded inserts get melted into the plastic on the other side, so they have to sit properly in the bits in the core. As you can see, this original core doesn't have any holes on the underside for threaded bits, but it does on the top. It does not fit in these holes that are already there. What I need to do is sort that out. Also, these posts here for holding the bridge on, I need to change them. I used the holographic pattern on this, but I'm not going to on that. That will just be on the faceplates from now on. So aside from the threaded inserts, I shall also be using a couple of these 6 by 12 posts, and as you can hear, the hole's too big on this side. So before I can print off anything that would be part of the final guitar, I need to make sure that the holes for holding everything together are actually the right size and in the right place. So to test that, we are going to have a look in FreeCAD, where I have started a new project called tolerance testing. So FreeCAD is completely free. It's quite fun once you get the hang of it. But essentially, create a body, create a sketch inside that body, select a plane. I'm going to select the XY plane. Get a rectangle tool, and what I want to do is hovering over this center point here. That will mean that when I start, it will lock it to that center point, and rather than having to drag and fiddle about, you can just put in your numbers. So I want it to be 60mm long and then we'll tab over to the other one, and let's just make that 10mm. So now that's all going green because it, as it says here, is fully constrained. So now that that's fully constrained, we can close the sketch, go up here to, apologies, I had forgotten that I was up there. So I'll just press cancel so that you can see that again. Here we go. Select our sketch, hit pad. Now it comes up asking us how we want to create it. I say we just make it 10mm. Use calipers a lot in this 3D printing game, young Sonny Jim me lad. And as you can see, the calipers are saying, well, hopefully you can see, calipers are saying that's 5.9mm. Well, the calipers are saying that's 12mm. So 5.9 by 12. I am going to select this face, which is the front face there. You can use this square up here to change your view. You know, if you want to look at the bottom, there we go. But there's the rear, top and front. So back to where we started. We're going to create a sketch on this face, and this time we're going to do a couple of circles. So for the circles, I'm going to put in 6.2mm, and let's put another just beside that. Okay, now they're not entirely lined up, but that's actually fine because what I want to do is have them a little bit offset, not too close to the edge. I might be tempted to push them. So they're slightly offset because I don't want them to be perfectly straight. Because, or do I? So, if you make your circles, put them in the wrong place by mistake, so let's select that one, then come over and holding down control, select that one so that they're both selected. Now up here, constrain horizontal, and you'll see that this one was raised up to the same level as that one. Now it's not right in the middle either, so what we can do is we can go up here for creating external geometry and select that line. So now we can use this line to determine a distance. So selecting the line, selecting there, and pressing D, that asks us what distance we want. Now we already know that that block is 10mm, so let's just put it bang in the middle at 5mm. So let's do that for the end as well. So let's go back to getting external geometry. We don't actually need to get external geometry because we do actually have this center line, but we select here, select the first circle, press D, and that's 8.1mm away at the moment, so let's just tell it 5 as well, and that has moved. Now we can select these two and D, and I want to make the distance between them not 25, 15. Actually no, we will do 25 because we want to make sure that everything fits, and that seems like an easy way to do that. So now that we have designed those two holes and they are 5mm from here and 5mm from here. Obviously they are also going to be 5mm from there, but we don't have to tell it that. We can close that sketch, and now we are going to add a pocket. Now that said 12mm, and I made the diameter 6.2. I'm going to make the depth 6.3. I don't know why, it just seems like a good amount to me. 0.3 of a millimetre is a tiny amount, but also if I'm going to add any glue, maybe 0.3 millimetres of glue will do. So, there we have them. Now, I would like to add 2 holes for checking the hole size for the heat inserts. So, pick this face again, create a sketch, pick our circle. Now, the calipers tell me that the bit that fits in, the bit that seats in, is exactly 4mm. And the very top, where it will engage with the surface, that is 4.6mm. So, I'm going to say 4.2 for the width for that one, and then the one beside it I'm going to put 4.3. Now we'll know that the one closest to the pegs is 4.2, the one farthest away is 4.3. And while we are here, we may as well constrain these. So constrain them horizontally first, and now D for distance, and we will make them exactly in the centre as well. I'm not too fussed about the distance between them, but also when you have selected a tool, just right click to close that selection. So 11, let's go with 15. Let us select the geometry for the end, right click to get out of that, select that, D, and we will make that 5mm as well, because that seems fair. Now those 2 holes are fully constrained. It is time to decide what depth. It says 5.6, so let's just go with 5.6 and see how we get on. Oops. What we're going to do is create another body and create another sketch, also along the same XY plane. Now I am getting the rectangle tool out again, locking it to that center point and going for 60 by 10. Again, as you can see, it's green because it's fully constrained. Right click to get out of that, then close the sketch and pad to 10mm. What I'm doing is that I go up here and click on that eye. I've made the body, the second body, disappear because I want to select this face, come up here to the part design menu and create a shape binder. Editing Gill here. I just want to say I'm really sorry. I didn't know that you couldn't see the menus and stuff. I'm disappointed. I'm disappointed in myself. Why do I always do this to myself? Now you'll see that appears in the other body, because that was, if the body is bold text, it is the active body. If it's not the active body, then it's just the plain text, but if you double click, it's now the active body. So we'll go back to this body, make the first body invisible, look at the second body. So I'll just tilt it a little bit so that you can see it, because I've noticed if you look at things head on in this, they're not always as clear. So what these shape binders allow us to do now is that we have this pad. Let me just switch the shape binder off a second. Select that pad, create a sketch, turn our shape binder back on, and now you can see that if I come back up to the external geometry and zoom in so that I'm just getting this line, then there we go. That gives me the center point for all of these holes, which is going to be quite important in a wee minute. Very Scottish there, wasn't I? So first we're going to do the big holes, and if we drag out, we will see that little icon appear when we get to 6.2. There we go. So click on the center point again, drag it out, 6.2, and that's then fully constrained. So close that. Pocket, that was 6.3. And that's those complete. Now, on this side here of what we're making, we actually want to remove quite a few mil. Pick the face that I want, which is this face here. Get our rectangle tool. Let's make that 25. But then for this side, we only want to leave 2 mil, and we know that it's 10, so we'll make that 8 now when we close out of this sketch and make a pocket. We will select that the pocket is 10 mil, and there we go. On this side, which you'll be thinking, oh, you can't see your shape binder now. Well, if I select on this and toggle transparency, then yes, I can. But also now what we want to do is select just this face, create a sketch. Now we're going back to external geometry, because that is the best way to make sure everything lines up, is to be referencing. For those holes, that's for these. Now these are very hard to see, but it's a bolt with a hex bit at the top, and these are M3. So what we are going to do with this is we're just going to make a 3 mil circle, 3 mil, click here, 3 mil. Now when we close the sketch this time, we're not going to add a pocket, we're going to add a hole. So when we click on hole here, we can go to this isometric regular profile, which is what I've been using. If anyone has better experience of hole tools. Now it says lets us pick the size here. M3. We'll go with wide clearance. It just makes it 3.6mm because 3D prints shrink as when they cool, so it might seem like it's perfect, then cool down and not be perfect at all. So for the hole cut type, countersink. There we go. Let's just zoom in a bit. Let me just check. It says the diameter of that is 6.10. So let me check the diameter of one of these screws. Yeah, that says 7. So this is why we're doing this, because it will make everything easier if we know what we're doing at the end before we even get there. So let us make the diameter 7.2. And we bring our other body back. We can see right through our screw holes. So that is what we have created. So now if I select this here, which was the last operation carried out. Oh, wait a minute, we have not clicked OK. Silly me. So now that we have clicked OK and everything is done, let us then export this as an STL. The drawer still has about a quarter of an hour to go, so we'll let that finish and then we'll come back and print out these parts in black and have a look at whether they are the sizes required. It has finished. You may notice that the inside of the drawer suffers from what they call stringing. Okay, so we have the hexagon. I've brought over the small clip. Wait a minute, so this would be the front. So there we go, from the front, but from the back. And it is actually shaped for plectrums. Although I do imagine that now, instead of people saying, I'm trying to find my bloody plectrum, I had it a minute ago, they were saying, my magnetic drawer fell out my guitar. Didn't hold them as expected. I think what I might do is revise this and put little slats down at the bottom to grip each plectrum, or just put a little groove along every once in a while to grip them. You know, I'm not complaining about the person's design. I think it's a fantastic idea, but personally I think the rattling would annoy me. Because I play very, very quiet. Very, very, very quiet. Very, very quiet. Very quiet. Let us quickly we have our... Oh, that is upside down, isn't it? Oh no, it's on its side. Which is actually how we want them to print. Can anyone in the class remember why we want them to print like that? Okay, so yes, we're printing them on their side because that is how they will print when they're on the big pieces based on how each section has to sit on the build plate. For instance, this some people would print this on the build plate like this, but I want to have it lying down. Initially that was because I was going to use the holographic, but I have realised that perhaps due to not having an enclosure in the middle of the night, this would start to lift off the bed, off the build plate, and you might even be able to see in the actual print itself you can see that there's a line here where that stayed stuck down to the bed, and everything outside of that line had actually lifted off the bed. So it is not actually flat. This again, so we have our two tolerance testing bits. Let's go to the objects, and we don't actually want them to be printing in filament 1. We want them to be printing in filament 2, generic PETG. So if we slice that, it should take 17 minutes to print. Don't really need to level the bed this time. And, oh! Seriously, I did not go and make a happy face in the poop tray. That sounds wrong. So just for anyone that's interested, that's the printer now received its instructions. It's switched on to filament 2, which is generic PETG, and it's now going to do a little poop, which will probably ruin the poop fate, or will it give it a nose? I said I would edit this down, but I don't want to. This is fascinating. This is like an Attenborough documentary. Oh, right in the mouth. So here we have the other bit. Yeah, that's pretty tight on there, and you can close it right down. So we know that each of these is 10 mil. So now we know that seats together perfectly. Right, so what I have noticed with this is that the one that I made 4.3 seems more comfortable, but also seems too tight. We will go back to our original design, and we have these two. And that's 4.2. But we're going to change that one to 4.4. And we're going to change this one to 4.5. We'll keep them at 5 millimeters. We'll keep them 15 millimeters apart. And when we close it, now we have our two new 4.4 and 4.5 holes. So I will just quickly print that just now, and then we will have a look at the heat inserts. So as you can see, they turned out really well, and now I'm putting the threaded insert in the 4.5mm hole, and that fits in pretty nice. And here we have the 4.4mm hole, where the 4.4mm, that actually feels even better. It's not too loose, and by using this soldering iron tip that is designed to fit inside these, this just heats them up, although you need to plug it in first. So when you plug it in, just hold it on the top of the threaded insert, and then at 250 degrees is what I've got it set to, and it just kind of slides in. Just don't go too far down. You want it to get to sit nice and flush. So by pushing the two of these down, the second one did feel a bit looser, but then when they're both down nearly flush, simply turn that over, press it down on the flat surface, and then you can just give them a little rub for good luck. And also the two 6x12 posts, they fit in. They're really quite snug, but that's good because we want them to be nice and solid, and with the top piece fitting on, that should hopefully have quite a tight hold. And it sits together perfect. So now we just have to see if the screw, if the heat inserts line up with the bolts. And of course these are flat-headed hex key bolts. These particular ones are M3, and I believe they are 6mm in depth. So they go the 2mm through and then 4mm into the heat insert. And with the hex head, that might seem a bit unusual, but anyone who's ever tried to get a threaded screw head out of a guitar will know if you can make it a little bit easier, then that's just going to be even more helpful. Although it's quite difficult to use the hex key inside the hexagons. But essentially, about a dozen of these bolts and a dozen of these heat inserts will be holding the majority of the guitar together, along with some epoxy resin. So here's our final piece, and as you can see, those bolts really do just sit nicely in those countersunk holes. So that's a very handy feature in FreeCAD. And with the posts, the screws and epoxy resin, that should be a pretty solid held together guitar. Now the third thing that I wanted to figure out in advance was this. So this is called fuzzy skin, and it helps to hide layer lines in 3D prints. As you can see, this really thin one at the end here, you can't see much, and it's quite smooth. But I think that maybe, this third and fourth one, they are a bit extreme. So here's the one that I'm thinking of using. It's very fine. If you look at the bottom at this smooth section, if I hold it just right in the light, you can actually see the individual layer lines, whereas this bit at the top, you can't. And it feels quite nice. These other ones are a bit rough, but I think that maybe the second one, I think perhaps the second one feels a bit more intentional. And of course this is what 15% infill looks like. So that's what the inside of most 3D prints look like. I stopped this one early so I could show you that. Just in case you're interested. And if you want to check the strength, this part was not too strong. That's why we want to make sure that the guitar is strong, looks the way we want, is held together, and feels nice. And of course these will be held on with the same screws in the same fashion, because this is 2mm, which is why I made the top section of this 2mm. So when we screw these on, the screws will not be too visible and you won't accidentally brush against them when you're playing guitar. I think that's enough updates for today. We've got some good progress, and the next thing we will do is have a look at FreeCAD for the guitar. We will have a look at the core. We will set all of the holes for the countersinks to the right size, and all of the holes for the steel posts to the right size, and then we shall start printing that out at 100%, which I believe might take 3 days. I hope that investigation into holes wasn't boring. Right,